Hey everybody, me Keith, Elder Rock, back on the bench. I'm sorry it's been probably 2 weeks since I've posted anything, but my day job keeps me busy. They had me out in the jungle doing testing and equipment verification. So the last 2 weeks has been very, very crazy. I've been in and out of the house here. So let's get started back on this Defender board where we left off. I almost forget where we left off. So let me recap myself and then you get to join. So the last time we left this Defender board, this is the later Defender board, the second set I've worked on here. This is the later Defender board, and we went ahead and we resocketed all the RAM. We resocketed the decoder chips, the CPU. I put new header pins in, resocketed the ROM board, headers, CPU. If you remember last time we had 3 ICs socketed here. We'll get to that in a minute. Those I just got rid of those and soldered the component straight into the board. So if you notice, the game is running. So last time we left, it was just rebooting, right? It was just resetting, would not boot. Okay, so in the last 2 weeks, really the only thing I've had a chance to do was probe around a little. And actually very little. So I probed around, and yesterday I spent the day here on the bench and kind of digging into what was going on. So let's catch you up on the troubleshooting. I'm sorry it's not on film, but I think I can walk you through. So let's go to the ROM circuit. So this is the ROM board section page selection decoder circuit. I was probing around, and what I found, I'll keep very long story short, what I found was between the 395, I think it's a buffer, and this decoder, 7442, was that a binary digit to hex converter? There was no signals. All of these were high right here. There was a lot of missing signals. And from this IC 14 to 7432 and gate inverter, I think it's not an inverter, it's a NOR gate, I believe, or NOR. But pin 8 had no clock, and this 395 had no clock. So this guy, it writes on the down from the clock. The trigger low, it should write out to here. Nothing here and nothing here. I spent a lot of time in the whole circuit. So basically, I could be wrong, but I think some of the circuitry, some of this output makes its way back around and enables some of the either IC 26 or 14. I think this is kind of all got to be working to have that clock. Okay, so let's go over to the ROM board because I want to explain. I want to tell you guys something. So down here on the clock, so this is the IC 14. Let me get my little map out here. 14, 13, and this is the decoder. This is the converter for the binary to hex converter. So what had happened, guys, I'm going to tell you about working on your bench. Things to do and not do and be like me. So these two sockets, this 139 and the LS25 were socketed, and I was working one day. I just turned on my solder gun, and I always tin it, and I leave a big glob because that's who I am. I pulled it out kind of fast, whoosh, and a big solder glob, like it fell like bird poop, like right underneath these two sockets. So I had to desolder. These two sockets, clean up the solder, and resocket them and go from there. So when I was probing around, I had all those missing signals. And yesterday I'm like, well, I did have an incident. I'm going to call it the incident. So I went ahead and pulled these just to make sure that there was no solder. I didn't miss anything and something was getting shorted. So this one, and this 395, which this is the one that had no clock and the converter. I was like, well, I'm going to desocket these. I'm going to go ahead and desocket this and check it in the retro chip tester. So it was kind of by pure luck. So anyway, that decoder tested bad. I'm sorry it's not on film. That decoder was bad. So I went ahead and cleaned the board, inspected it. I put everything back, and guess what? It booted. So after that, it booted to diagnostic mode. The game would actually start, but it was resetting. So it was not fixed. So running through the diagnostic mode, it was coming up ROM 1, ROM 2, and all of this. So this is where we're going to start in on the next section. So the game was booting after fixing the decoder. Kind of checked the PIA, everything down here was good. But it kept on coming back in diagnostic mode. Let me see if I can get it in diagnostic mode. Yeah, right here where it says all ROMs okay, it'll come back failure detected ROM 1. And then so again, I had checked all of these ROMs multiple times. I dumped them. ROM 1 was the only ROM that was not original in this set. And I verified it yesterday like 4 or 5 times. The original one, I compared them. I burnt some extra ones. And I got a new one in here last night before bed. And then it was still coming up ROM 1 failure. So this morning I had an idea. I dumped this ROM set before I even did anything, like before the desocket. So I went back to the original ROM 1 dump, burned that onto a chip, and now you can see all ROMs okay. So let's take a look. Let's take a look at those ROM files because I'm still not 100% sure. I'm going to show you guys. Okay, Defender Red Label, ROM 1. If I go, let's Red Label dump. Let's go up a folder. Let's Defender Red Label, ROM 1, Defender 1, submit. Okay, comes up Defender Red Label 1. Then we can see the checksum down here, kind of 0974 checksum, fluke signature 2541. So let's go back and let's drop in. Oops. Let's go back and let's drop in the one that came with the board, ROM 1 that came with the board. Red label dump. ROM 1, submit. Okay, ROM name, Defender 1, Defender, red label. But check it out. Checksum is different and the fluke signature is different. So they're both red label, but they are indeed different. So if you ever run across that, make sure you dump all your ROMs when you get a board to work on, because you may have a hard time finding it or lining it up. The red label that's online, the red label ROM, will not work in this board. I tried several different ROM chips, M2716s, AM2716s, some Motorola, some STs, and I didn't know what to think. But let me look one more time. This is the dump. This Defender 1. Let's go back and check out the other one. This Defender red label. Defender 1. See, same ROM name. So I don't know how MAME is built, like their database, but they got two identical ROM names, descriptions, and all of that, but different checksum. I'm going to go check it one more time. Offset D000. Okay, Defender 1. Let's go back up. Let's go to my dumped ROM. Yeah, see, the offset is the same. Yeah, and even, let me show you something else. Even if we go, let's open this up in, oh, good, they're still open. So I already had them open in here. So let's go plugins, hex editor. We're going to view that in hex. Let's bounce over to this one. Let's view in hex. Don't matter which one you compare. So if we compare, and I've already been down through here manually, I did not see one bit of changed code. So let's go compare. We're going to set this one to compare. Bounce over to this one and compare. And then check it out. ROM 1 bin and Defender 1 match. So even in hex editor, they match, but I don't know why. The one will work in the board and the other one will not. So FYI, be careful of your ROMs, and it's really easy to go down the rabbit hole of troubleshooting and checking, and I did yesterday. I checked every pin on the ROM board, pin to pin with the oscilloscope. I was about ready to take that socket out and look underneath it, but it was the ROM. So anyway, okay, so let's continue. That's enough on that. So let's continue. Let's get the game running. We have a lot of work to do today. We have a lot of work to do today. Let's get the ROM. Let's get the game running. Okay. So from yesterday, now we're going to talk about the noisy power on this. So kind of troubleshooting the ROM issue, I want to talk about chip select 3 on all 3 banks. Chip select 3 is tied high. Should be tied high to 5 volts on each bank. And actually over on Arcade Classic Repair, Sean, I once I saw this, I remember Sean's video. Sean over at Classic Arcade Repair had the same problem. And I was looking at this yesterday. I'm going, man, the signal. So let's look at the signal. Chip select 3. If I can hold the pin on here and talk at the same time. Okay, I have the oscilloscope set up on a half second, 500 millisecond sweep. So it's pretty noisy, and it's actually not as noisy as it really is. See what I did here? I put a big ass capacitor between my line and my ground to try to get the power down. So that's chip select 3 on bank 1. Let's go 1, 2, 3. Let's go chip select 3 on bank 2. Look at that. Look at that. Let's wait until almost 2 volts. So this being a chip select line, the problem with that, if any of the pull down voltage hits a threshold, the trigger threshold, it will totally jack up your gain. The chip will be trying to select off that line. It should never try to select. It should be high all the time. Over 2 volts. That's crazy high. 1, 2, 3, 4. Now let's go chip select bank 3. If I can stay on the pin. Not quite so bad, but again, I have this big capacitor in. If I pull that, okay, I'm just going to pull it. And you should see it'll go up to, yeah, see, going up to 1.5 volts without that capacitor. See, the downs are pretty crazy. I want that nice and tight. So let's look at some other 5 volt signals to let's go over to the CPU board. Let me get on a 5 volt at the far end of the CPU board. See that? More stable. It's not as jumpy. There's not as much noise in that. So we have less than a volt, 800 millivolts of noise. I'm not worried about that. That's looking okay. So And let's go to the 5 volts right on the connector. Whoop, if I can find it here. Let's go to the, oh, that's not the 5 volts on the connector. I have to find it, guys, sorry. This one? Okay, not that one. But anyway, you get the point. Let's come back to the CPU board. Let's do some 5 volt probing over here. Let's look at the 5 volt just on some ICs. I don't, nope, not that guy. Nope, not that guy, sorry. No, I don't know why my scope is acting like that. Unless I'm on the wrong, I'm not on the wrong one, am I? 5 volts. Okay, let me tag. Is it doing that? It was set just right. Okay. Oh, I know why it's doing that. I'm on 1 volt division. So let's put that back on 5. Or yeah, why is it doing that? Okay, never mind that. I'm not going to get into that. So these resistors, the R1, R2, and R3. So these are the pull-up resistors that they have engineered in. They're 330 ohm resistors. So just like over on Sean's video, I'm going to put in 0 ohm resistors and try to get that signal pulled high. Another thing I'm going to do, you have to be aware of, noise is a very common place for noise to come in is your wire looms, your cabling. So what I'm also going to do, I'm going to put new pins on this ROM connector. I think this one came with the board. So if I probe back here on the 5 volt line, let's probe right at the power supply. This is really what I wanted to show you guys. Now I got my scope all jacked up. Gosh darn it. I don't know what I did here. Okay, never mind. My scope is not cooperating while I'm filming. My scope is not cooperating, people. Did my crown come off or what? It may have. My scope, like this little. Oh, I think I seen the problem. All right, now let's try it again. There we go. Now I gotta adjust this. 1 volt. Okay. Wait 1 second. 500 milli. Okay, well, I'm sorry, I don't want this video to be long. I'll dial that in when we cut. The point is, I know I have clean power coming in off the power supply. This 5 volts looks good. This 5 volts does not look good. So I'm going to put a new pin here, put these resistors in there. We're going to cut. We're going to come back and we're going to check out those signals again. Then there's more problems with this board. We're not done. The game is running. We're close. And then we're going to go after, I got problems with the interface board, and then that's next. But let's get this power taken care of, and we'll move on. Okay, so I'm just going to let the camera roll, since I have a film crew today. Okay, so let's just get started. Power's off. We're going to, okay, first we're going to, let's get these pins out of here. And use a little screwdriver. Yeah, I don't know. Kind of like I was saying earlier, you know, your cabling. Me and my friend Steven over at Frankenstein Arcades, we have the same theory. We both have trust issues. The only cable you should really trust is the ones that you build yourself. And I did not repin out this, so yeah, we're just going. Yeah, the crimps look okay, but you know that even copper, I mean that noise could be coming. It's kind of dirty. They have both crimps on their wire, but it just could be the connection between two different metals. So let's go ahead. We're gonna snip those, strip them, and just get some other. Then we're just gonna get some other pins put on. We got to be careful. They're both the same color. I'm gonna have to follow them back, see which one is, which one's what. I like to come in just, yeah, about like that. Looks nice, clean, bare watt. I used this cable because it's actually pretty good quality. It's actually stranded copper, old school. So not old school. It was manufactured. It was manufactured before things got cheap. And a nice conductor size in the middle. Okay, let me grab my clippers. I'll get those new pins. We'll get those new pins. Alright. Keep dropping stuff here. I don't like to work over my board sets too much. Let's get that guy in there. Guess I didn't have everything I needed, but it's an arm length away. From my other video before, it's just how I like to do it. I like to hold it up in there. I like to hold it up in there, give it a pinch so it holds on this side. Dun, dun, dun. Let's give it a crimp. Wait, no, that didn't work out very good, did it? Give it a pinch. There we go. All right. Chuck this guy up in there. Inspect. Good. Give it the pole test. Yeah, that guy ain't going anywhere. All right, let's get this other one on. Dun, 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 dun. Yeah, we'll get these pinched on. I got the desolder gun heating up for these resistors. I probably didn't need the desolder gun, but I figure since the whole board's been cleaned and reworked, we can clean all the pads and stuff. And we take those out. Crimp that guy. Line it up just like in my video. Yep. Felt good. Inspect. Looks good. Okay. Compare them to the old ones. So the old one is interesting, actually. The old one is interested. The old one is actually, I don't know if you can zoom in on that, but check out this old one I just cut off. It has guides, side guides. So actually the old style pin, you're going to get 3 sides of connection. You got the flat surface and each side. Those are actually better than the ones I just put on. But they are dull. I probably could have just popped them out and cleaned them maybe, but whatever. Yeah, those are actually nice. Now that I know they have that style, I'm going to try to look for those and buy those. I totally get this. Can you see that okay? Yeah. So it has a track that goes down around the pin, so when you slide it down in the pin, it's like that. You get 1, 2, 3 sides of surface. I will look for those next time. Yeah, it feels pretty good, but whatever. I just repinned it, so I got to make sure I get this guy stuck in here the right way. So this one's ground. This one's ground. Could use my meter, but it's not that long of a cable. This one is ground. This one is ground. Okay. And ground was, don't second guess myself here. Ground was this side. Pop him back in, make sure he locks. And then positive, not too much guesswork there. Pop back in. Kind of tight. That's okay. Yeah, what's your problem? I'm actually putting it in the right way. Okay. What is your malfunction? Yeah, pushed up in there. Really shouldn't go up in there that hard. Alright, well, he just wants to be a pain in my ass, I guess. Everything looks okay. He should go right up in there. There's nothing up in there. Yeah, I've always, oh, there it goes. Went right in that time. Okay, I just had to give it a little twist. Alright, new pins on that guy. I think everything else has new pin, but I learned something. I like that style pin. That's deluxe. That's the pin that I want to use. Now I see these, I'm gonna have to find those. Okay, so got that. Let's get these resistors out. So let me get some stuff disconnected here, and we will go to work on this guy. Okay. I think the ribbon cable is actually okay. So I love my blocks. If you don't have blocks on your bench or something like that, I highly suggest them. So let's get these guys out. We're going here, here, and there. Okay. Got my solder gun on ice and heated. Let's get those guys out. The goot. The goot. Okay. Yeah, looks good. Thinking we're just going to leave that on because I have a feeling we're going to be using it over on that interface board. So let's see if those guys will pop out without too much problem. Yep. They're probably still good. We might measure those just to see if they were failing or what the deal was. Let's see, might still have solder sweat a little bit. Wiggle that. Alright, let's grab. Now, yeah, be careful with your solder gun if you're working around or near your boards. should not be working over top. All right, let's just give this some extra heat, and that guy should lift right out. Dun, dun, dun. There we go. Yep, just take your time. Like I always say in all my videos, take your time. You're gonna rip pads and damage stuff. This guy, let's just get a little heat on him and pull right out. All right, so you can see the holes there. Let me grab. I wasn't planning on filming this, but that's okay. I like filming, putting content out for you guys. Oh, right there. There was little flux under there from when I resocketed. I didn't have any good IPA when I cleaned these boards. I had run out, and I was actually had a chance to go to the market 2 days ago, so I got another bottle of IPA. Help dissolve those down. Okay, so let's get into our 0 ohm resistors here. Get 3 of them. Yeah, had a pretty good time at the market. I actually found some smaller wire. I used, what is this, 0.8? 0.6. And I wanted to try some 0.5 mm and some 0.4. I actually wanted 0.4. I found 0.4 and I found 0.5 mm. So I'm going to try them both. After, I'm going to use up this roll first because, yeah, that was a 1 pound roll, right? No, quarter pound. That's still a quarter pound roll. That's a lot of solder. we burned it up, guys, together on Arcade Laboratories. We do a lot of soldering. I'm a weirdo. I like my legs nice and even. I like them nice and even. Get them in there. Hopefully I got it. Yep, I think that's okay. Get him down in there. Yep, nice and centered. Low profile. Let's get these other ones in. Just hit them all at once. How I do it, guys, I don't know. Like when I place parts, I use the thickness of my tool because I know, like, it's like, is it a full width or like 3/4 of a grip, and that's how I gauge. And like that, if I use that as a gauge on each side, it's like the through holes are just a little bit shy of one length. So I just kind of look at it. That's one length. I come up here about 3/4 of the way of that length and give it the bend. So that's how, you can use your tools as a guide, as a measuring guide. Come out here about 3/4 and give it a bend. Yeah, the one that's just not quite right. So we're going to do him again. There we go. Yeah, it looks better. And I like my bends to be the same, like a nice, like if the rolling bends or sharp bends, it just kind of depends on the component. But I like them to be the same. I don't want like a rolling bend on one side and like a sharp bend on the other side. Doesn't look factory like that. Okay. Get him down in there. Yep, looks good. Yeah. I mean, I knew this wouldn't take long. He's going to be about the same. Give it the bendaroo. Yeah, people probably have their own ways or whatever, but that's mine. That's mine. Nice, clean, sharp bends, even, ding, ding, and probably pretty close to the through hole. Yup. Excellent. We'll get him down in there where he goes. I think what we'll do, and when I like them, I like my parts even too. I don't like one end up higher than the other. All right, so I'm actually going to tack those in from the top. Not a big deal. just so when I flip it over they don't fall out. Yeah, let's get in here and just get a little solder on one side of those. Oh, I actually pulled him up a little. That's all she needed. Oh, there she goes. Okay, let's flip it over and finish it off. Yep, that's okay. These guys straight. All right, let's finish these guys off. Snip it. Yeah, I love the soldering. I love the soldering part of this hobby, of this work. I was a welder for a long time, and it's a lot of the same. It's just smaller, but more so I like the circuitry. I like the math part of it. But the soldering is definitely a skill. It takes time, takes practice. Okay, let me grab the little snippers, clean those up. Okay, I'm going to save those. I was actually looking for some of those legs yesterday. Let's, I just want to hit those, clean them while we're here. I don't have to come back and hit them later. Just hit that little bit of flux. Probably gonna clean this whole board later. I've been all over it. Let's just kind of clean that up. Flux, at least this flux, or you should clean your flux off before you power up. It can be conductive, in my opinion. I mean, even if it's a low resistance, but there's a potential difference. If you have a bunch of solder in between your legs, a voltage potential there, so probably good to just kind of clean up your flux. All right, cool. I think how'd the other side come out? Pretty good. Got good through hole solder there. All right. So got our pins. Got our 0 ohm. Got our 0 ohm resistors. Okay, let's cut there so I can adjust my scope. So back here we got a little bit of I want to show you guys the results of putting in these 0 ohm resistors. I ended up putting this is a filter cap on this Ram board. I put a larger one. I put a it was 100 microfarad 25 volt. I put 1,000 in. It's just a filter cap. I think that capacitor can get away with a larger capacity there, just to help smooth that out. Didn't get the results that I was hoping for. I might have actually made it worse. So let's probe around a little bit and I'll show you guys. Okay, so on the pin, we repin this connector coming in. So now we're at about 1.7 volts. Noise in that line. Oop, that was me. I was expecting that to be lower. So last night I actually had jumpers across those resistors and it was going down to like 1.3 volts, but it's up there. So let's hit resistor 1, the 5 volt side. So we're getting about 2 volts now. So it really didn't help, but the average, it's a higher average. So I think we got about the same coming down, voltage noise coming down into the trigger range. It might be the same. See, that's going 2.24 volts. Not what I expected. I gotta show you guys everything, the good, the bad, and the ugly. Let's see, that's bad. It's definitely ugly though. Resistor 2, over 2 volts noise up there. Resistor 3. Let it sweep, get a good measurement. Yeah, about the same. They're all about the same now. They were different before. So let's probe up on that chip select 3 line. Yeah, we're getting a 2 volts in that. 1.8. It's not horribly worse. And it does look like the average is higher. It looks like everything is a little bit more pulled high, a little bit, like the average. I don't see the spikies coming down. 1.68. That's not the end of the world. I got a whole stack of Defender boards, so I'm going to keep working on this. I'm not so sure it's not my cable. Oh, and the problem with the scope before, guys, was just a bad cable. When I bought this scope used, like the grounding test point, it's corroded. It has some rust on it, and I can't keep it off. So it's kind of goofy to keep a good ground on there. 2.2 volts, and then the chips on bank 3 would be chip select 1. Gonna be about the same. 2.2 volts. I'm going to keep this in mind. I'm not going to rebuild my harness right now. The game is running. But let's check these other. Let's go back down to the power supply. I want to show you guys, like, back on the power supply. It's lower, 1.7. Let's check the other 5 volt line. Could have swore that was a bit lower before. And then check the other 5 volt. Yeah, 1.7. Not the end of the world. Let's check it. So let's check this far RAM 5 volts. Let's see yep, see that's way better on the CPU board. Yeah, there's definitely some noise. I think this was actually a bit lower. I think these were less than a volt before. But I think I'm going to come back to that. I think I just want to get to this interface board today. I'm going to think about this line noise. So we're like 300 millivolts up. But anyway, good, bad, the ugly, I thought I would show you. And definitely something to keep in mind if your chip select 3 is high, or you want to measure that when you're troubleshooting this ROM board, just to make sure the noise isn't trying to select something. Okay, let's cut there. Board. Nope, I think we're gonna roll right in. Okay, 1 minute. Let me get set up. Let me get the plug back in my service switch. All right. Okay. So, actually, before we start here, I'm gonna get the where's the interface board? We got IC5. IC5 is pull up. IC5 is the pull up. Is that IC2? Fuck is that? IC3? IC2 and 3. And IC. Are you recording? Oh. Okay, guys. So I guess my film crew, they didn't give me the signal. All right. So checking out, we have problems with the interface board. So you can see I'm in the test diagnostic mode for the testing. So we got some weirdness going on. Up is constantly on. So now if I run through some of the other controls, left is coming up hyperspace, down is coming up smart bomb, fire is not doing anything, down is coming up over here on smart bomb, and warp is reverse. So we're missing a lot of stuff here. High score is okay. Oops. Oh, I should have taken it out of advanced mode. Let's just go back. Let's go back. Okay. So we definitely have some goofiness. I was just kind of looking at the print there. What's going on? I don't think this will be too hard to troubleshoot. Okay, so come down here on the print. Let's walk through this a little bit, and we'll probably get the logic probe out for this. So it looks like from 3J2, which is this guy, I'm pretty sure, the connector. Yeah, 3J2. 3J2. So we're looking at it kind of like that. 3J2, we only have ground, and I think that's down. And then 3J3 was the rest of our controls. 3J3 coming in here, 3J2 coming in here. So our service switches work okay. Well, that's over on the other board. Don't even worry about that. So it comes in through resistor, comes in through IC5. This guy is a resistor pack IC. Then it comes through. I was looking at. I think that's IC2 and 3. So IC2 and 3. These guys are inverting gates. And then looks like an what is that? IC257. I don't know if that's a buffer or selector into the PIA. So I think we'll just get the logic probe out and we'll just start with up, find where up is stuck. I don't know if it's the PIA because it could be, I guess, but we something shorted out. And I know my test module is good from the other Defender. So it's not this guy that I know of. Something shorting out, I think, in here. I'm guessing in here because if these guys were wonky, then we would get kind of what we're seeing. So let's cut there. I think I'm gonna get the tripod out for this, and we'll go and probe around together. But I'm gonna find where up comes in the other controls, and we'll just start over here at the connector, work our way through, and I think we're gonna find this guy pretty easily. Okay, let's cut there. We'll get the tripod going and see you in a minute. Okay, me and Keith, we're back. So we're back, and we started the troubleshooting on this. I started the troubleshooting on this. So I found out something very important. I had built, yes, my test module works fine, and I built it on the Defender early version. And guess what? The pinouts are completely backwards. They're exactly the same, but backwards. So keep that in mind. So I repinned out my connectors, and guess what? The game works just fine. We'll coin up. We'll start a game. And we've got thrust. You can't really see. We got thrust. We got reverse, up, down, fire, smart bomb, and warp. So, boom. So yeah, nothing wrong with this guy. Nothing wrong with that. I'm happy. I don't have to do anything with that. Okay, so yeah, I was all prepared. So just kind of showing you, I printed it out. I was gonna go after troubleshooting, and I got into the first thing. I was like looking back on fire and realized that fire here didn't line up here. So I pulled up the early Defender set, and you can see the pinouts are just backwards. So like pin 1 on the later, you have fire, thrust, smart bomb, hyperspace, player 1, player 2, start, and yeah, they're just backwards. So this is I made it to be a Williams test module. I'm not gonna do anything too crazy today because I have some jousts. I got like 2 joust boards. I got some Robotrons. I have some Stargates. So I will probably in the future make an adapter for this. So after this board, then we're moving on to joust. So I will probably build I probably will build adapters for that, for the test module, so I don't have to repin them every time. But I want to think about like a cool, easy way to build that adapter. So I guess we're going on to the soundboard now. So the soundboard had some weird problems. Like we did a little bit of troubleshooting from the last video set. I've ordered cap kits, but I don't know. They're probably still a week off. But I think the problem was that potentiometer. So we're going to go ahead and connect up the soundboard and look at that. And we're going to look at that soundboard. I bet it works too. So, all right, we'll be back in a minute. Okay, hey guys, we're back on the bench, and I'm so sorry it's such a mess. Hopefully, like someday back at our other location, I'll have a way bigger bench. Okay, so got the soundboard out. Everything's kind of good with the rest of the board. Now we're messing around with the soundboard. Okay, so right now I'm in diagnostic mode, and I'm just letting the tests run. Okay, so the problem with my soundboard, I am not getting anything out of the output of the speaker. So I'm just kind of probing around. I have my little homemade 5-watt amplifier. I call it my audio probe. So I can kind of probe around, preamp, and see if sounds are generated. I can use the oscilloscope too, but it's nice to be able to hear the sounds and see what they sound like. Okay, where to start with this guy? I got the blueprints out. So I am concentrating here. And I think in the previous video, probing around, that was like a couple weeks ago, I determined, yeah, everything is generating okay up into the input of the volume control. The output on this side of the potentiometer, the out of the volume control into this amplifier, this whole side is dead. So I'm going to show you, we're going to probe around a little, and I want to probe around on this side, on the output of the potentiometer, and you'll see like we have nothing, into pin 1 of the amplifier of the op amp, the output of the op amp, and there's nothing here. You know, I actually put in today a 50K potentiometer here. This is like my third potentiometer, just kind of rule that out. And when we get up to the op amp, things get a little bit crazy. So you can hear the sounds. Another thing I don't like, that I'm not convinced is this amp. Another thing I like, when I reset the game, I don't get the proper sound at boot. Like, I'll just do it, and we'll just go back and do, let me turn this up a little so you can hear. Okay, so when I reboot the game, hear that? That is not the sound it should be making. So let's go back into, yep, see, and playing the game, not all the sounds are there, some sounds are there. And let's go back into sound diagnostic. And a lot of that, there is a lot of noise from my audio probe. Okay. Okay, so right now, where are we hooked onto? I just tagged onto a ground. I'm tagged onto a ground, and I am on resistor 11 right now. Yep, I'm on resistor 11 right here. That's preamp. So let's take this guy off. Okay. Let's just get to the bread and butter here. So we're going to go IC1, and all the other boards I do like this. So the sound should be coming through the potential. Actually, let's hit the potentiometer first. So like just pretend that this is your gain potentiometer. Input, same sound. Volume control works. I kind of been messing with that. Then your regulated sound out. Now listen to that. That's on the amp side of this potentiometer. I think that amp is causing all that noise. Now let's go a step further here. We can look at it with the probe. That's actually making sound. Now if I come over to the other side of the potentiometer, the output side, the volume control output side, to the amp and to the speaker, that's what we have. So, okay, let's continue on. Okay, so we're going to go right on the amp. See you later. My filming staff is leaving. Okay. So pin 1, I guess for you, is going to be the one on the left. So that should be our input. We should have roughly the same sound as the input side. So that's the sound input right into the op amp. I don't like it. There's no sound. But then we could actually go to the output, which I already know is from pin 4 of the 2002 amp to this resistor. I could probe right on the amp, and I hate I am gonna find like a good set of these clamps. I freaking hate them. So on this side, there's nothing. On the output of that amplifier, there's nothing. So you can see, if you can actually see there, coming, I guess, from the right hand side, pin 1, 2, 3, 4 has a trace up to that resistor, and there's nothing there. So I'm going to change that guy out. I got one sitting here. I got the solder gun all heated up. So I'm going to cut here, do a little work, and we'll come back and we'll probe around together. You know what? I decided to film it. Not the prettiest view for you guys, but we've been this far together with this whole set, so let's just kind of finish it out. And I apologize. I need to practice what I preach. About a clean workbench and all this room and this, that, and the other. But I think at the moment we're just gonna kind of take what we have in small village Thailand. Okay, let's get this. I probably don't even need to take him off, but I kind of want to look at it. Is there value added taking him off that heat sink? I don't think so. I think I can leave him. If I have problems getting that other one in, we'll pull it off. I got the solder gun over here. Let's let me try to get these guys out. Hopefully the tip I've got will work. Yep. Oh yeah, she's loose. Hopefully she comes out of there okay. I think I could have used the next size bigger tip. Yeah, I may have problems with this one, guys. Oh, God, I hate when I do that. Relax and be careful. I think, what do I got in here? I think I've got I got my 0.8. Gosh darn, I got my small tip on. So we might have a bit of a problem. Yep, I'm gonna have to put a bigger tip on if I want to desolder those. Yep. Yeah, I'm cheating now. Yep. Okay, well, before I butcher this board, let me get the right tip on here. We'll suck that out, no problem. Okay, be back. Well, actually, I got my other tip right here. Doesn't take too long. Okay, there's my 0.1 tip. Let me swap him out real quick. Hot swap, guys. Yeah, working over my board. And we're just gonna do a hot swap. That thing is freaking blazing hot, but that's okay. Yeah, the Goot, a little different from the Heiko. I know a lot of people uses. It's got the heat tube part of it. Let me get my I like to dump it in my solder gun tray because it's freaking hot. There we go. Alright, let's put this guy in. It shouldn't take too long to heat up. So let's let that guy heat up. I think the 0.1 tip will actually get in there and clean that. Or big enough for that pin. I know for other pins, like header pins, I got to go up bigger to the 1.5. Looks somewhat clean from last time. I wonder if that's the one I broke. I think that's the one. Yup. I got to get a new one. The cleaning tool, the cleaning rod I use, freaking snapped off in there again. I don't know if you guys can see that. Pisses me off. Something fierce. Little cleaning rods. Sometimes, like, the heat, I think, contracts down around there. And then when I'm cleaning it, I'll be pushing it in and out. And they're so high tensile. And they just fucking break. And these things are like, even here, these tips are, listen, I don't know. They're like $9 or $10 each. I mean, they're, yup, that tip is broken there, off in there. Let me take him out. And I'm just going to chuck him. It's probably hot now, but alright. Yeah, I don't know if you guys can see that. No, camera won't focus. Oh, there it goes. See, you can see the cleaning tip broke off in there. That sucks. So, let me get a new one. I've got a new one here. I might go with, I think just the 0.1 is okay. Alright, I got a new one here. Let me get this guy going. Alright. Nice fresh cleaning tip, or solder tip, desolder tip. Get him in there. Yeah, the Heiko, I think that design, it lets that whole tube and tip heat up fairly fast. Maybe, there we go. I'm just gonna pause, let this thing heat up, and be back. Okay, we're back. The new tip is heated up, and off camera, I retinned the tip while it's new. So, got a little bit of a stretch here. It's hopefully the 1 mm is good. Yep, it gets right down over. Let's heat that up. Suck it out. Oh yeah, that's nice. Got it good. Alright, it's a tight fit, but it goes. Yeah, that's a nice clean extraction there. Alright, put that guy down. Let's flip him over. Hopefully got all the solder up on the top. Might be some sweat left. I think she's loose. Let's give these back to a little bit of a wiggle. I can't reach him from the other side. Yep, there it goes. Flip that guy around, just pull him out. Okay. I'll test him out of circuit. We'll test him out of circuit later. TDA 2002. That's what our replacement is. So it does have, okay, let's see. I'll show you guys. Wow. 2002 TDA. It does have a Mylar shield to the heat sink. I don't know if you can see it. Yep, you can see it. And again, they didn't apply thermal paste the way I like it to be applied. Let me get my thermal paste. Let me get my thermal paste, guys. Dun, dun, dun. I got a tube of it right here. So really okay, let's dry fit it first before I make a mess. Just want to make sure that the legs are bent proper. Once I put the thermal paste on, I don't want to be smearing it everywhere. I think that's close enough. Okay, dry fit's okay. Let's get some thermal paste on there. I'm gonna leave that Mylar on. They didn't get. See what I don't like? They didn't coat. Oh, you know what? I'm wrong, guys. I thought there was a Mylar shield there. My bad. No, they just put a spot. You see how they? I don't know if I'm going to try to zoom in. See how that's not like a nice square shape? When you use thermal paste, you need to coat the whole surface, the whole surface, so it transfers the heat properly. So I don't like when they do that. Actually, I might try to clean that off a little. Do it proper, right? Let's get some of that old stuff on there. It might be burned out, who knows? Or not burned out, but the properties might be not so good. If we're gonna put new, we'll just put the new on and get that old crap off there. Get a little bit of. Just clean that a little. Yeah, there it comes. Okay, I can deal with that. A little bit of alcohol. Still got a little crusty of the old there. Let me get my brass. Let me just I'm having a problem getting decent brushes too. There it goes. Okay. Nice and clean. Got all that old crap off. Let's, okay. I actually got to pause there. I got a call coming. 1 minute. Okay, we're filming. Okay, so we're back. I had my phone call out of the way. Sorry about that. So, okay, let's get our thermal paste, put on this guy, and try doing it without making a huge mess like I always do. But at least I can show you how I do it. That's way more than enough. So this whole part is going to get hot. And that's why I don't understand why people don't. I'm just going to use my finger. That's why I don't understand why people just don't coat the whole thing. They put like a dab on, think it will smush out, and it does not. So you want to coat the whole thing, the whole back surface, so the heat dissipates properly. Okay, let's get this guy. Let's grab him, drop him in. All right, let's get him where he goes. Okay, back 2 holes aligned. There we go. That's about it. What I like to do is just I like to get the hardware started, kind of hold them in place. What? Okay, let me look at the back here. Make sure I've got enough so I don't have to cut it when I'm done. I think that's fine right there. So let's get the nut started. I got a little gunk on the thread, but that's okay. Let's get him started back on. Yeah, it's dangerous kind of working on stuff. You know, you don't want to, always worry about handling and damage. And we've got a lot of stuff here on the bench, but nothing too hard, hopefully. Okay, before I torque him down, let's take another look. I don't know if you can see. We are right here. That's just about right for soldering without having to cut it. So let's hold on to that heat sink and that guy, and let's give him a torque. All right, he's torqued down. Good stuff. We'll just double check, just take a peek, make sure that there's no shorts. That one leg is kind of close. I think I'm going to push that guy up just a little. There we go. I like that. All right, let's flip him over, solder him carefully, get my solder gun over so I don't drip solder. Okay. Get the solder. Yeah, let's I'll actually take time and zoom in on that for you guys. Now, whether or not this wants to focus, that's another question. Right there. Something like that. That's weird. The camera, it focuses sometimes, and if I can get like super close. Something like that. Let's solder these guys in, be done with this, and then we'll fire it back up and see what we have. Let that solder run down in the hole, and we'll add that, and we can add. Okay. Yep, let it flow. More on this guy. We'll come up here, fill him. Let it get down through the through hole. Don't add it too cold. You want to see it sweat down through the through hole. Yeah, that one did good. I think that's okay. All right. Kind of messy there a little, but well, just the flux makes it look awful. Let me give it a little bit of a clean while we're here. Notice all of that flux is all nice and warm. Let me get a little. I don't want any contact. I don't want anything in between there that could actually. Yeah, I use like a toothbrush sometimes, and I have like a paper towel over here. I'll kind of wipe the flux, and we'll come back and get the majority of it later. Yeah, it looks pretty good. Solder okay. Yeah, let me look. Yep, good to go. All right. So let's flip this guy over. Making room, all the crap on the bench. And let's see if any of those signals or anything looks any kind of different. Zoom out here. Get this board set in here. I do have cap kits coming for these. Let's see, make sure nothing got jostled around or anything. All right, let's power it up. Got nothing through the speaker. I got nothing through the speaker. Got two blinky lights. I'll take that. All right, let's get back to the sound diagnostic. All right, there we go. So nothing through the speaker. That sucks. So there's something else going on. I don't know if you can see my potentiometer here. So there's a speaker inside my box, and it apparently doesn't like what we're doing. All right, hit him on the ground. I hate these things with a passion. Let's I am gonna try to clip him onto the ground here. Hopefully he stays. And let's go audio in. Now we got weirdness. Like the Buck Rogers all over again. Alright guys, so alright, well let's start probing back. Let's check that op amp out. We're gonna go right to the input of the amp. Not good, right? Crap. Well, I actually got adjustable sound now. Okay, I'm going to cut here, do some probing around, and well, let's look at, let me do some probing around. Oh, hey guys, me Keith, Elder Rock, back on this bench with this Defender board. This is a continuation. I have no idea what part we're in. Okay, so I think we're getting very close to this board being okay. So let's start with the soundboard. So remember yesterday, and in all my Blue Label videos, we were having sound issues. So I found the problem. and it was, again, operator error, just like I teach my students. And I should have been onto this sooner, but when I picked up the stack of Williams boards, it came with a jumper from the soundboard to the ROM board already configured. So basically, long story short, guys, it was pinned out completely backwards. This is a straight pin out: 2 to 2, 3 to 3, 4 to 4, 5 to 5, 6 to 6, 7 to 7, 8 to 8. So with the other issues I found, I decided to take a look at that today, and indeed these were completely backwards. So I repinned out the connectors, and it works fine. So let's go into the sound test. Now you can hear, and I fixed up my box today too. All the sounds are great. So let's do a boot. The speaker is in here, so I totally fixed this guy. Got the speaker in here. All right, no ROM failures, no RAM failures. Gonna boot again. So let's go into diagnostic mode. Okay, that's the soundboard. I just feel like an idiot, but replace the amp. I'm gonna recap it once the caps get here, but it has sound. It's good to go. PIA is okay. CPU is okay. 6808. Very nice, clean board. Everything's working. All right, let's advance. Okay, so I don't know if I showed it previously. Right here, I was getting a CMOS Ram failure. So what I did to go through this, to troubleshoot this, and I'm glad it didn't take me long. So basically, I came to the CMOS Ram read-write protection circuit, and following these gates around, I want to show you guys something too. So I was probing the gates. So what I ended up doing was I closed this switch on the header pin. So basically you can do that here. Pin 1, you can ground it, because right now it's high. So high indicates that the coin door is open, which is the position that it needs to be in when you run this test. So if you ground it, it pulls it low. So the first gate, 5B pin 3. 5B pin 3. The guy right here next to it. So, this guy. I think somebody's already been through here troubleshooting and trying to fix this before. So now if I remove, I'll remove that jumper, and it goes high. So basically you can run through the whole circuit like that. So troubleshooting, all these gates were working good. Okay, something you guys need to know in the schematic, 4J, pin 4 and 5 is wrong. Data address line 7 actually lands on pin 4, and pin 5 goes to your 5B pin 4. So this is crisscrossed right here. This is not right. And I buzzed it out and can prove it. So anyway, the output of that gate was working okay, but when I got up to 6C, let's probe around on 6C a little bit. Pin 1, 2, and 3, which is 6H, the first guy right here. So I've got now this is a CMOS 40, what's it called? A 4071, and it's basically 6 OR gates, I believe. I just pulled it up. Let's look. So if you don't recognize it, it's a dual input OR gate. So kind of looks like that. Now I don't have one of these, but I have the TTL equivalent, which is a 74LS32. So I jumped. Let's take it off here, and I'll show you guys. Let's take that guy off. We're still passing. If I were to run the test right now, it would fail. Let me go back to. Let me go back to the diagram here. Pin 1, 2. Pin 1 and 2 are the inputs. Pin 1, that's from the read-write on the MPU, main processor unit, so we have some data. Pin 2 is coming from 4J6. It's coming from 4J6, we're working right here. Coming from pin 2, coming from 4J6, it's low. And then pin 3, now the output, look at this. It has data on the lines. I'm not sure. I think that's supposed to be just a logic change. I'm not sure if that guy is supposed to have data on there or not. So let's jump it. So I have a 74 LS 32. Where'd it go? 74 LS 32, which is a quad input OR gate. I think OR gate, right? Sorry if I messed that up. All right. Now let's probe around on there. Okay, pin 1, which is coming from the MPU. Pin 2. Have a little bit of a change in pin 3. So see, we still have the data there, but it's passing the test. So I don't have the CMOS equivalent, but I'm going to pull that chip. We'll test it in a retro chip tester, and we'll socket it, and we'll put that 32 in, and should be okay. So I did probe around. I should probably show you guys this. The coin cell's 3 volts, so the battery's charged. I followed it back around to here with the game off, and I wish I had another set of hands or a tripod for this. So when the game is running on your voltage pin, you should get 5 volts. Or whatever the board voltage is. And then when you shut the game off, I'll probably pick that up on the scope. You can see, I don't have my voltage measurement, but we got 2.5 volts. So the CMOS Ram 5051 should store and operate down to 2 volts. So right now we got 2.5 volts here, but the reason we have voltage drop across these diodes. So something to keep in mind when you're checking voltage. You're going to have some voltage drop here, and there is a mod I saw that you can use 2 different diodes here and not get so much of a voltage drop. But since we're at 2.5 volts, I think I'm just going to roll with it for this board. I might come back and swap those out. Yep. Oh, I'm on the wrong one. Okay, boom, 2.5 volts. I need to set my measurement. I might refilm this a little bit, give you guys a better understanding. So that's the thing with how to troubleshoot a CMOS failure. Come here to your read-write protection, and then you can ground and unground this switch, this coin door, and watch your gates change states all the way through. Now this was tricky because, like I just showed you, this really didn't show a gate, like a big logic change, but I'm going to swap that guy out because, and we'll look at it later, I think some of that noise is going to go away on that output. I think it just it's just bled through or shot or something. So we're going to test that in the retro chip tester. Let me get the desolder gun going. We'll desolder that guy, pull him out, and we'll be back. Okay, hey, I'm back. Me, Keith, Elder Rock, we're back. So when we last left off, I suspected this 4071 2 input OR gate of being bad, because when we jumped the TTL equivalent of 7432 over it, we came up with CMOS Ram OK. That was after checking all the gates, you know, from the coin door switch to the 5B to the 5B to the 4J, 5B to the 4J to the 6H. Everything acted normal. So check this out. So I got this 4071 in the retro chip tester, and off camera it tested bad like 4 times. Now it's testing good. I wish I would have got the testing bad, but now it's testing good. I don't know, guys. Wish I had a good answer on that one. I don't have another 4071. I'm going to get one and I'll replace it in here, and that will tell us if there is something else going on in that circuit. I don't think there is. So like basically the difference here is your trigger and threshold levels. I can't remember the exact voltage. The TTL and the CMOS, well, CMOS and TTL, they trigger at a different level. Their logic levels hit a little bit higher. Maybe that guy was bad, and then putting him into the retro chip tester, like, gave it, you know, straightened out its gates or something. I don't know. So, but if we probe this guy, we're going to see the same signals as we did. Okay, so input gate 1, we have our data, and I think the voltage is about the same. Input gate 2 should be a logic 1 or 0. That looks pretty good. And then the output, and that feeds the read write on pin 20 into the CMOS RAM chip. So I might throw that other one in and maybe take a closer look at this. Maybe the gates are working okay, but not under load or not with data, or maybe it's corrupting the data. Because if we go over to the read write line, let's see, 20, see 11 pin, 22, 21, 20. So read write on the CMOS looks good. Might throw that other chip in, but actually we'll do it. We'll do it right now. Why not? I can do it one-handed, no problem. And we're gonna do live swap here. And I have to say that was actually, let me shut the game off. That was a tough chip to get out, or it was not wanting to come out, but I got it out without causing any damage. And let's throw this back up. We just looked at it on the scope. Wait, let's look at this one on the scope as well. All right. So we'll get it back into diag mode using my handy dandy. All right, my handy dandy homemade Williams test module. So I wanted to put a switch. Okay, let's not even talk about that. Let's go manual. Go back up into auto. Okay, so with this other chip in, we got failure, right? So let's test these inputs again. Oh, wrong chip. There's a little bit of noise, and there is a little bit more downshoot. little bit more ringing in that data. See how some of the lines are really going almost a volt lower. If you watch the bottom, almost going a volt lower. So let's go to the output. Output looks okay. You know, maybe you'd have to put a logic analyzer on it. See see those data bits? There's data bits not coming all the way down versus the other one. Let's go back to the read write. Yep, see there's data bits. It could yep, there's stuck half data bits. Maybe that chip is just shorted enough to pass on that, but in reality, not gonna pass. Okay, one more time. Let's pop this guy out. I like my long screwdriver. I can get into things without really bending. Okay, here's the 32, 74, 32. Let's get him back in there. Fire up the game. Yeah, I know. The color thing on the TV is my TV setup. That's not the game. FYI. Okay, let's let the game boot. Take it back into diag mode. Okay, CMOS Ram, okay. So let's check that. Let's check those signals again. There are some, well, there are some higher, there are some bits not coming all the way down. See, I don't think those are ringing down in voltage as much as that other one. Okay, this is the output, same chip. There's a lot fewer half data bits as well. There are some shorty signals up there, but nothing like that other one. And let's go back to the read-write on the CMOS Ram. See, yeah, there's not nearly as many half data bits, quarter data bits coming down. So maybe that's the problem. Not sure. Anybody has any feedback there? I would listen to theory on that. And why it's passing on here, I don't know. Maybe it's just intermittent enough under load with actual data going through. If that's just checking the gate states, I could understand, like, if you had data like the address bit 7 coming into one of the gates and it's just getting kind of lost or shorted out a little bit internally. But hey, I'm going to roll with that. We're going to get a 4071 down the line. And man, that's about going to finish it up with this board, guys. I am so happy to finally say that. So we're going to do a wrap up. We got a couple other things to talk about. I need to get my sync worked out and get these colors right. And I know it's the colors because my other Defender board, it looks the same way. See how the color's kind of off? I think that's to do with my either my sync circuit or like crappy, something wrong with my cable. See, it's not right. If the game is running, I'm sure the colors are okay, but we're going to verify that. And then I think that's about it. I think the next video we're going to do like a final wrap up. This is gonna be like 6 parts, but this has been fun. A lot of lessons learned. Okay, so that's the CMOS Ram, guys. A little bit of troubleshooting on that guy. I'm happy we fixed it. Okay, till next time. Hey guys, me Keith, Elder Rock, back with finally the wrap up video for this Defender Red Label PCB. It was a long-winded one. If you guys made it this far, yeah, kudos to you. If you made it this far, let me know, and I'll send you a Arcade Laboratory t-shirt. How's that? Lets me know that people are actually watching my videos. So, if you want an Arcade Laboratory t-shirt, let me know. You made it this far. Okay, so we're just going to wrap up this video saga, and let's just go over some lessons learned. What was wrong with this, what I learned. Now this was my first, between this one and the Blue Label, this was my first Williams board set using original power supply. And let's just go right to it, at least with this Blue Label. So, first lesson learned, cabling. Always verify your cables with the schematics. So with the controller, with the interface board, the pinouts are backwards, completely opposite of the Blue Label. So I had incorrect wiring harness, fixed the control cable. For the sound, the same way. This cable came with all these board sets I got. I assumed, awful thing to do, I assumed that the pinout was correct. It was not. I repinned out the ROM to soundboard cable, and it worked fine. But she did, in the process, get a new op amp, and when I did not recap this because they just didn't, the caps didn't make it in time. But we'll go back some other time and work on that. We learned about, it had funkiness with the ROM set. The ROM 1, there's two versions for the red label, so be careful. So we had bad ROM label. Also on the ROM board, we had a bad binary bit to hex bit decoder was bad. That kept the game from booting. Replaced that, the game booted, fixed the ROM board, okay. On the main CPU, we did the sockets, headers, caps, everything here was okay. I can't remember. I think all of the socketed ICs were okay. I don't think I changed any of these out. I think we got, yeah, we did good. Replaced these, no damage. The CPU board was okay. Just gave her a cleanup, and she was fine. CMOS Ram. CMOS Ram failure was the, what was that? It's a, 4271 NOR gate, dual NOR gate IC. Swapped it out with the equivalent 7432 gate. The game works. So fixed the CMOS problem. Everything looks good there in that circuitry. So I guess that's about the wrap up, guys. You can see the game is working good. It's been on for like 12, 13, 18 hours. Running well, not resetting. So I guess the big lesson here for me was, assuming that cables are good, even, you have to pay attention to the schematics, especially within certain manufacturers. They just make these changes that can really bite you in the butt, really make you go down rabbit holes. So I'm really excited about this whole thing because I actually got my Defender test module working. That was part of the sound problem, right? I had the negative from the speaker to the potentiometer swapped around. That was my fault. And so going into the future, this will be a great test module for the rest of the Williams boards. I'm going to have to make adapters. This thing will get modified, definitely like for Robotron, because Robotron has dual controls. So this guy will get modified in the future, plus with some adapters. And also for if you guys build a module like this, I did have to add a separate ground for the service switch side, because the service switch connectors land into the ROM board. So if you're testing without your controller board, you will not have a ground and your service switches will not work. I guess another thing on your, if you build a module, a test set, I'm going to do a whole separate video. An on-off push button switch will not work for your auto up, manual down. You actually need a switch for it to work properly. So kind of keep that in mind. But that was a good thing. We fixed we fixed this board. I got the module squared away. And I think we're going to quit there, guys. This is a really nice board set. It's clean. I don't think any other work needs done. I finished it all. For the sink, I will go back, because this does have an option for composite sink. You have to cut a trace. So I'm going to go ahead and jumper that trace. That will put the sink back onto the horizontal and vertical sink lines, which if this goes back into a cabinet, you need that. So when we go back to the blue label, we'll have to use our sink module, but that's okay. And man, that's about it, guys. Long video saga. I learned a lot. I hope you learned a lot. So hit like and subscribe. Any comments? I'm learning, so if there's some other things that you saw me do wrong, please correct me and I'll update my video with that. But okay, we're gonna put this one, we're gonna wrap this one up for good, and we're gonna go back to the blue label. That's next. We're gonna finish up the blue label. I think the sound problem, the interface problem was the same problem I had here. So I think we're gonna go back to that board, finish it up quickly. I am still waiting on a ribbon cable. I know for sure I have a bad ribbon cable on that blue set. So blue set, and then by request, the next one we're going to do is going to be a joust. We're going to do the joust board, and I'm excited about that. I have the original transformer. I have a power supply coming from Anthony over at Quarter Arcade. I have my ribbon cables. So we're going to do the same thing. For the joust, we're going to rebuild the power supply, and we're going to refurbish that whole board. New sockets, new everything. And anyway, guys, thank you for watching so much. I hope this helps you a lot. So leave some comments for me. Leave some likes and thumbs up. So, hey, catch you on the next video.